Good morning and good afternoon if you're in the UK. This is a relatively short presentation with some slides and just some information about some of the latest technology and basically what we're up to. And as said, there will be some questions afterwards. Okay, so effective quality assurance of THT production with AOI systems. Covered in this will be a brief introduction to Goepel and who we are, production faults in THT or through-hole process, components and solder side. What does effective inspection mean? THT production process and integration options of AOI systems, OptiCon THT-Line system concept, configuration options and various software modules, and communication with traceability systems, ERP software or MES software. So customers develop and manufacture high quality products. Modern products are based on PCBs. Their quality needs to be ensured, and they need to obviously pass stringent environmental tests both in the lab and in the field. Goepel's motto is get the total coverage. Business units cover JTAG, boundary scan, various different software and hardware configurations. We have an automotive test department, functional test, industrial vision solutions, automatic X-ray or AXI department, automated optical inspection as well. Goepel was founded in 1991 as a spin-off from Carl Zeiss in Jena. Jena is a university city in Germany. And Goepel started off with a small number of people, and they now are getting very close to 250 members of staff. They have distributors just about everywhere. And they have direct branch offices in the USA, France, China, India, and the UK. THT production process, fault possibilities, inline concept, integration options for AOI systems. This is really just an overview of circuit boards and where our machinery can help production minimize faults and trace and look at improving the process. If you'd listened to all the SMD guys 20 years ago, you would believe that there was no THT boards being made now, but THT boards are still alive and they're still flourishing, and particularly when there are high voltage or power requirements or power feed, there is still a direct desire and need for THT components. So what production faults can we have? Well, we can have a number of faults. We can have, particularly with hand assembly, we can have missing components, we can have a wrong component type, a wrong component value, and incorrect polarity. These are all very common things, particularly if there's hand assembly going on, and even with automated assembly. On the solder side, again, when the boards come up the other end of the wave, you can have shorts, you can have missing pins on devices, you can have insufficient solder, you can have holes, and you can have solder balls as well. So, is AOI testing necessary? Yes. If you want an effective inspection, then yes, AOI test is necessary. You can have high fault detection. You can test within the cycle time, so you do not cause a bottleneck on the actual production line. Cost-effective rework of detected faults. It's far better to detect the faults before they go into box build, or even worse, before they go out to customers. Integration into the production process. A lot of Goepel's machinery is inline, which is completely modular, so it will go in line and it will be seamless within the production line itself. So the actual output of the production line will be unaffected. And return of transport for the carriers. Again, if this is a through-hole production line, and if the boards are manually being populated, normally they will be on a carrier as they go through the wave solder, and the return transport of those carriers have to be thought about as well. And space-saving use. Again, with the modular concept, the machines fit in the line and have no direct impact on the production line whatsoever. So a typical production process will be manual loading with wave soldering, manual inspection, unloading and for rework, and return of the carriers without the PCB, where the carriers will go off to either to inspection or they'd go off to box build, and the carriers will be returned to the start of the line. With the THT line, if you're inspecting on the component side only on the first pass, you go straight from the manual loading prior to wave soldering. And the advantage is you can repair detected faults without the need of soldering, without the need of desoldering or soldering. The fault clearance is directly after detection, so that board is then removed and sorted out, whether it's got missing components or reverse components, without actually interrupting the line. An inspection of the solder side, integration options in the production process. This is after wave soldering, so we're inspecting after the board has been soldered. The disadvantages: an additional AOI system is necessary, and the high temperature of the board and the space that's required. So how can we have a machine that would inspect the component side and the side? So the THT component side is in the upper part of the transport module, and the THT solder side is in the lower return part of the transport module. So the PCB will travel from manual loading through the THT line, goes on to be soldered, goes through the transport module, has the carrier lift and the carrier return, and as the board is transporting back along the carrier return to be manually loaded, the solder side can be inspected. The advantages that are we can repair of detected component faults without having the need to desolder or resolder. Less required space, we only need one AOI system, and we have lower temperatures of the PCB when we're inspecting the solder side. Okay, system concept, configuration options, and different software modules. The AOI module for the component inspection is a camera module, CCD matrix, up to 24-bit color depth. Inspection height for OCR is 0 to 60 mil. For presence and polarity, it's 0 to 80 mil. The maximum component clearance is up to 80 millimeters, and the resolution is 35 microns per pixel. With that resolution, we can have an inspection speed of up to 60 centimeters squared per second. So we're talking seconds to inspect the component side of a board as opposed to minutes. We have a massive inspection area of 540 mil by 450 mil. And the carrier size to transport your PCBs is up to 620 mil by 510 mil. The AOI module for solder joint inspection, again, camera module, 24-bit depth. The inspection height is 5 mil, and the component clearance is 20 mil on the bottom side. The resolution is 14 micron, or 28 micron per pixel. The inspection speed is up to 100 centimeters a second. And again, the same inspection area. The inspection area is 540 mil by 450 mil, and your carrier size is up to 620 by 510. Capable to be integrated into the upper transport module or to the lower return module. So you can have the underside, the solder side inspection for the carrier return, or you can have it as if it was post reflow, you can have it in the midsection. I think that's fairly self-explanatory. So we've got the first picture is a top side only with a return carrier underneath. The second picture horizontally is the top and bottom solder inspect as if the machine was placed after reflow, waste solder, sorry. And then the two lower areas, we have one where the solder area is being inspected underneath, and the bottom left picture of a machine is purely a machine which is checking for the solder area post flow solder. There are some diagrams now showing you the different types of clearance and the clearance needed for OCR and for character reading to make sure that we have the correct component fitted. And it is same with the underside. It shows you the 20 mil clearance that we have for the PCB, and combining those two in a single machine, so we can have up to 80 mil clearance for the top side, and we have 20 mil we can have for the bottom side. So we can deal with some pretty high connectors and pretty high electrolytics and wired components. Illumination, all about illumination. Illumination is absolutely vital. It's a multispectral, multi-directional top flash illumination, which is RGB. We also have a quattro flash illumination, and we have a meta flash, which is ultraviolet and IR. These are really for the different types of solder joints that you can expect to see, and for the different types of lighting for components. If you have a component that for OCR, for example, if it's laser marked directly on top, you have to have an angled camera, illumination to show this up. If you was looking straight down with a straight down illumination, you wouldn't see that. Similarly with solder joint, multispectral, multi-directional is used for components and also for the solder joint. Test functions. So what can we test? So we can test for the presence of a component. Is it there? Is it not there? Polarity recognition. Is it the right way round? OCR. Is it the right value device? We can also read the color codes on resistors. So this can be quite a useful one if the wrong bandolier is put into a machine, if you're using automated insertion, or if you've got the wrong resistors in there. We can read the value of the resistors that are on the board. As we can read, as you can see in the pictures here, we have on the bottom right, we have an electrolytic, and we're checking for the polarity, and there is a tolerance on that polarity as well. Test functions for solder joints. It's flexible illumination, and we can check for insufficient solder, solder balls, shorts or bridges, missing pins, and that sort of thing. It's the multi-spectral illumination really does show this up very well. Basis for efficient use, safe and documented inspection quality. In the OptiCon reference database, you can have, well, in actual fact, you can have 100% inspection saved. What most people do is have any failures picked up and saved. So at a later point, you can go back and you can check with the serial number what this board status was as it went through the AOI system. And if there are any failures, you can actually have a snapshot, a picture of that failure and where it was. Also, what you can do with that is that you can optimize your test programs. Most programs are relatively organic in the fact that they evolve and they improve over time. You can also obviously pull off statistical information and detailed documentation, so you can have that, and that can be on the traceability, that can be per board, per production run, per hour, per day, per shift, per week, per month, and again you can see what your level of faults were, how many parts were tested, how many parts failed per board. If a board does fail, the board goes over to the failure station. On the failure station or the repair station, or even a verification station, the operator would see an image of the board or the PCB with exactly what the problem is on that board. And as you see, the picture here is what the repair operator sees. Failure statistics. This is quite a useful tool if you're a line manager or if you're responsible for a production line. Again, you can have an instant overview of any particular failures on any particular product or shift or day or hour, or a snapshot as the line as it is in the last 10 minutes or an hour or something like that. The real advantage with this is that you can see immediately if there is a particular problem. For example, the R6 is always failing because it's the wrong value, or this electrolytic is failing all the time because it's the polarity is round the wrong way, and this will show up very clearly statistically over that batch of boards or that today's production run, what was typically a failure. And that information again is very useful if you're managing a line. Also, the failure statistics can be visualized on a given product on an area, so you can see very clearly the predominant failures. Integration of production process, communication with traceability systems. This is something which we are seeing an awful lot more now. More and more companies do have traceability software, and Goepel responded to that with a system of data sets that can integrate and communicate with MES and ERP software. And this can be very useful as well, because we have customers where their boards will not progress further unless they have a pass signal from an AOI machine or an AXI machine. And really, the whole idea of this is that the machine is passing boards and communicating that information to the MES and the ERP, so that again with the MES interface you can see the complete overview of what is passing, what is not passing along the line. Specifications to processing one product, process clearance and response. Again, this is still talking about the traceability system with the MES and ERP. This is where the machine is the AOI system is communicating with the traceability software, and at any time you can get an overview on the MES or the ERP interface and see exactly where that board is in the production line and what stage it's at. And that transfer of data is automated from the AOI system and also from the verification or repair station, where the fault is classified. Possible interfaces that we have, unidirectional, file transfer, XML and ASCII, bidirectional, and TCP/IP. So ours are done typically by file transfer, and they're normally unidirectional. Goepel manufacture a complete range, from solder paste inspection to automated optical inspection to automated X-ray inspection. They manufacture inline systems for cellular inspection and verification, and also standalone systems which are inline. The inline systems are fully automated and work on the SPIMA technology with conveyors either side. So the effectiveness of an AOI system in the THT manufacturing process depends on its integration options. Flip-free double-sided inspection of THT assemblies affects time, space, and cost savings. The whole idea is that the AOI system should not slow down the production line in any way, shape, or form, and it should not have an impact on the production line throughput. Again, there are a number of different options and a number of different hardware and software modules which will enable that for you. As far as a test is concerned, flexible illumination and configuration and configurable test functions are required for maximum fault detection, and also communication with your MES and ERP software, which is something which we see an awful lot more of today. And that's about the presentation. And I would like to thank you all very, very much for your patience and your attention. Thank you.
Daniel, thanks very much. Nice job. Lots of useful information there, and we've already got some questions coming in. What I would say to other members of the audience that want to ask questions is, there you go, please go ahead and do so now, and feel free to put those questions through, and I'll just start firing them at Daniel in a random order. First of all, Daniel, question here: do we need a PCB flipper so that the solder side can be at the top side for inspection?
No, you don't. You can have the solder side inspected exactly as the PCB is presented. So you have the components on top, and the solder side is inspected underneath.
Okay. And in terms of the quality of the board, how much does board warping after soldering, after wave solder, affect the AOI quality? Does that cause any problems?
No, it does not. No,
Okay.
warping is compensated for.
Okay, because it's something you're used to seeing and expecting,
Yeah.
I guess. Yeah, of course. Okay, and there's a couple of questions that kind of fit together, and that is the where can we? It's the kind of where can we see this system question. Do you have systems already implemented somewhere, and do you have any reference sites or somewhere that people can actually see a system working?
This depends obviously on your location. If you're in the UK, unfortunately we don't have a THT machine in our Cambridge office. So what I would do in the UK is I would arrange a visit, possibly to go to Jena in Germany, where Goepel are, and we can go to their showroom and see the machine in all of its configurations,
Right.
Which will make life a lot easier.
And if people are elsewhere in Europe, there are various different options, I guess.
Yes, there are.
Yeah. Okay. And here's an interesting one. Can the AOI system check two different projects at once? And what they're suggesting here is that PCB 1 would be checking pre-solder, and 2 would be checking a solder joint post-solder wave.
Yes, exactly that. One of the configurations of the machine is exactly set up to do that. So
Okay.
the top side of the machine is checking the component side on one PCB, while the return carrier is bringing a PCB back along the production line underneath, which has already been soldered, and
Okay.
the AOI is automatically checking a different PCB on the solder
Yep.
side.
Okay, excellent. Just going back to the thing about systems implemented, I've got a an audience participant here from the United States asking, are there any machines available to look at in the US?
To be really honest, I don't have that information,
Okay, so
but
we can
I can
answer that
certainly,
question by email, and or we'll pass
yeah,
that on to
certainly,
one of the US agents. Okay, that's
certainly.
absolutely perfect. How are you managing tilted components coming from
Again, there is a
manual
tolerance
installation?
on those defined in the program.
Right, okay. And how does THT inspection work with a finger type palletless conveyor? Hmm.
A finger type palletless conveyor.
Yeah, so in terms of how the
The way
boards
that
are, I
the
guess you
conveyor
take over
inside,
the conveyorization of the board once it gets to the machine, don't you?
yeah, we take over the conveyorization of the board as it enters the machine, and
Yeah,
it's then returned to the, the 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 existing conveyor system as the board exits the machine.
yeah. Okay, and I guess there's no issue with space at the side of the board. You've got that kind of
No,
minimized.
no, that's right.
Yeah, yeah. Okay. Question here that you might not want to answer and you might want to follow up by email, and that's what's the average cost of a system?
That's definitely one which, again, very dependent on the machine's hardware configuration and what options are required for that particular production line. So that would
Yeah.
probably be something which I would prefer to discuss and find out exactly what somebody would require first.
Okay. I've got a question here. It's again from the USA. It's my understanding that approximately 5% of AOI inspection applications are for THT versus a very much larger applications such as SPI and SMT AOI. Do you have any comments on that? And I guess that's the mix of THT, and I think what you alluded to earlier in your discussion was when SMT came out, everybody thought that THT wasn't going to exist
Was
anymore.
dead in
But
the water.
yeah,
Everybody assumed that THT was a bit in the dust
yeah,
15 years ago, and
there's
here
no
we are
silver bullet.
15 years
Yeah,
later, and it's still here.
yeah,
Um, I think really that the way that Goepel think about it is that they focused for a long time on surface mount and SMD component inspection, single-sided and double-sided,
yeah.
and it was really a case of, hang on a minute, guys, we've got people making THT assemblies
Mm,
here. These guys could deal with it, could do with inspection at the same time.
yeah, yeah, yeah. Okay. Again, many assemblers in the industry will have a portion of boards assembled by machine and on site and hand placed parts at another
Yes,
site. Okay.
yes.
So is there like any desktop not inline models that can test both sides at once?
There is a standalone system that you
Right.
can have. It's pretty much identical to an inline system, but it is designed to work on its own, if
In
you
a
like.
standalone
And that's the
environment.
sort of thing that you could put a board in, and you can put
Yeah.
that in. You can put that in post flow solder, so it can be soldered, so you can check the solder side as well at the same time.
Okay. Okay. And we're just going back to that question earlier about carriers because the person who asked has given me a bit more clarity there. They've said the carrier used for inspection is actually used also for wave soldering. Would that be correct? Is that, the carrier
Yes,
that maybe the board's in?
yes,
Okay, it would be
yes,
the
that
same
is.
competitor. Okay, next question I don't think we're going to answer because that's who is your biggest competitor, and it's our competitor's job to talk about themselves, not us. We can chat to that person offline. Any limitations in the bottom side? Any
Clearance.
limitations if the bottom side has THT and SMT components? So does that
Uh,
cause
the,
any problems?
the only limitations we have, if you want to inspect both sides, are simply that the top side has an 80 mil or up to 80 millimeters clearance,
Okay,
and the bottom side if you are inspecting the bottom side as well,
Okay.
only has a 20 mil clearance. So if
Okay.
you have a double-sided THT board,
Yeah.
you've got to be a little bit careful about your component heights on both sides.
Right. Okay. That makes sense. Okay. Is there a conveyor feature able to sort failed units from past units? So,
Uh,
spit them out in different
what our
directions.
machine will, yeah, we've had that one before as well. What our machine will do is our machine will generate a pass or fail signal via SMEMA.
Mm-hmm.
And there are a myriad of companies out there that
That do those
produce
automation
a
solutions.
split level
Mm.
conveyor system to feed off any machine called failed boards.
Okay, and that's using the
The SMEMA
standard
interface, yeah.
signaling. Yeah, yeah. Okay, excellent. Um, can the system inspect for adhesive coverage and or conformal coating coverage?
For conformal coating, we do have machinery that can inspect for conformal coating, but it's not in the standard THT machine. That will be probably be a separate machine.
Okay, and can you inspect for shorts in untented vias?
Untented vias. That would be something which ideally we'd have to have a look at
Right.
the PCB if
Yeah,
possible before I can give you a definitive
yeah,
answer on that. Because
yeah,
if I put my thumb up in the air and say yes, of course we can,
yeah,
and then someone gives us a board and you look at it and go, ooh, I didn't realise that they were there.
yeah.
So it's really something which we could do with having a look at.
Okay, okay. Well, that's the questions I've got. And a couple of questions I wanted to ask was kind of the speed of the system that you're putting together. Does that, if I've got a production line that's got a certain pulse rate on it, is it possible to meet the challenges of inspecting the pulse rate of a production line?
Absolutely.
Yeah,
Absolutely, Phil. To be honest with you, I mean, the inspection time on the THT machine, we're talking in seconds as
right.
opposed to minutes.
Yeah. So it would fit very comfortably in a reasonably
Yeah,
high speed
the
production
whole idea is
system.
that it should not make any um, hold ups, or it should not slow down any
Yeah.
production line process.
Yeah. And as we see, developments of new devices and talking about new technologies in the industry like wearable electronics and all these things, it seems that we're more and more involved in hybrids and mixed technologies. Is
Yes,
that a trend that you're seeing and something that you're kind of, I know you mentioned earlier the automotive sector and sectors like that. Are you keeping in touch with those sectors to make sure that your technology roadmap is ready
absolutely.
for what's coming in terms of components and assembly
Well,
methods?
we certainly try to.
Yeah.
We certainly try our best to. We talk to a lot of people out in the field, and to be honest, we tend to get a lot of our development ideas from feedback from people.
Okay.
So it's absolutely critical that we do keep our finger on the pulse and find out what people want.
Okay. Daniel, you've done a great job in sparking interest because there's still a couple more questions that come in before we finish. Someone's asked if there's a review station where it can be manually confirmed, where you can manually confirm or
Absolutely,
reject the machine's decision.
absolutely,
Yeah.
absolutely. A verification station, yes, absolutely.
Yeah. Okay. Oh, and that's the same question that we were asked before. Can the system inspect for adhesive coverage and conformal coating? We'll cover that one later. Okay, that's all the questions I've got at the moment. If anybody else has got any more questions for Daniel or for any of the worldwide team at Goepel, do email in to editors@emsnow.com. And that's a kind of catch-all email that you can email any questions you have. We will be dropping you an email after the event with some more information where you can get some more data, you can get the PowerPoint presentation, and you can follow up. And Daniel and his team will be in touch as well in the short term. Do keep an eye out on EMS Now over the coming days for the archive version of the webinar, and you can feel free to forward that to any colleagues so they can take a look at the information that you've gained today. Keep an eye out for any other webinars that we've got coming up. And in the meantime, thank you so much for all attending, obviously from all different parts of the world. And Daniel, thank you very much to you for speaking to us and taking part today. Thank you very
Very
much.
welcome. Thank you.